Hello everyone, I am Tejas. Today we'll be discussing an important topic from automata theory and compiler design. Let us learn how to convert NFA to DFA. NFA means non-deterministic finite automata and DFA stands for deterministic finite automata. A non-deterministic finite automata, that is the NFA, can have a transition that goes to a number of states for a given input and state. A computer program needs precisely one transition for a given input from a given state. The process of converting NFA to DFA eliminates the ambiguity and allows a program to have a compiler construction. Reducing to a DFA can reduce states and transitions. Let us start with the steps for converting NFA to DFA. An NFA can have 0, that is null, 1 or more than one moves from a given state on a given input symbol. On the other hand, DFA has one and only one move from a given state on a given input symbol. Steps. Step 1. Convert the given NFA to its equivalent transition table. For each state in the NFA and each input symbol, determine the set of states reached by the following transition rules. Construct a table with rows representing the states and columns representing the input symbols and cells containing the set of states reached. Step 2. Create the DFS start state. The DFS start state is the set of all possible starting states in the NFA. Step 3 of converting NFA to DFA. Create the DFS transition table. Instead of individual states, the rows and columns represent set of states. For each given input symbol, the corresponding cell is in the transition table contain the epsilon closure of the set of states obtained by the following the transition rules in the NFS transition table. Step 4. Create the DFS final state. The DFS final states are the set of states that contain at least one final state from the NFA. Simplify the DFA. Simplification of DFA is very important. Remove unreachable states, remove dead states, merge equivalent states. Repeat step 3 to 5 until no further simplification is possible. This is the last step, that is the step 6. We repeat steps 3 to 5 until no further simplification is possible. The final DFA obtained is the minimized DFA equivalent to the given NFA. The final DFA obtained is the minimized DFA equivalent to the given NFA. Converting the following given NFA to DFA. Here we have three given states, that is a number of states is 3, that is Q0, Q1 and Q2, and the finite set of input symbols are A and B. Let's get started. Step 1. Here on transition of Q0 with respect to A goes to Q0. As we can see in the transition table, it is represented and it can be easily identified. Transition of Q0 with respect to B goes to Q0 and Q1. Transition of Q1 with respect to A goes nowhere, so we represent it by null. And Q1 on transition with respect to B goes to Q2. Q2 on transition with respect to A goes to null, and Q2 with respect to B goes to null. Here Q1, Q0 and Q1 are the new states. Now let us go and do the transition for Q1 and Q2 together. Here on transition of Q0 and Q1 with respect to A is equivalent to the transition of Q0 with respect to A union of transition of Q1 with respect to A. Here we get Q0 as the answer, and then we again do the transition of Q0 and Q1 with respect to B, that is equivalent to transition of Q0 with respect to B union of transition of Q1 with respect to B, and we get the answer of Q0, Q1 and Q2, which is the new state. because the Q0, Q1 and Q2 weren't together in any of the above states. Now in the step 5 we again do the same thing that as above, that is transition of Q0, Q1 and Q2 with respect to A is equivalent to the transition of Q0 with respect to A union of transition of Q1 with respect to A and transition of Q2 with respect to A gives us Q0 as the product, and transition of Q0, Q1 and Q2 with respect to B give rise to transition of Q0 with respect to B union of Q1 with respect to B union of transition of Q0 Q1 with respect to B gives us the product Q0, Q1 and Q2. And then as we can see on representing it in the DFS transition table, we can see all the states and their transitions. That is, transition of state Q0 with respect to A goes to Q0, transition of Q0 with respect to B goes to Q0 and Q1, and transition of Q1 with respect to A goes nowhere, and transition of Q1 with respect to B goes to Q2, and transition of Q2 with respect to A goes nowhere. Transition of Q2 with respect to B has no destination, that is nowhere. Transition of Q0 and Q1 with respect to A goes to Q0. Transition of Q0, Q1 with respect to B goes to Q0, Q1, Q2. Now the transition of state Q0, Q1, Q2 with respect to A goes to Q0, and transition of Q0, Q1, Q2 with respect to B goes to Q0, Q1, Q2. Hence, the ER diagram for the DFA can easily be drawn. With respect to the table as above of the DFA, we draw the ER diagram here. As we can see, Q0, Q1, Q2, Q0, Q1 and Q0, Q1, Q2 are the states. Here Q2 and Q0, Q1, Q2 are the final states. Q0 is the initial state. Thank you.